These are solutions to Melham's Calc 3, Exam 2, the 5 p.m. section. Okay, number 1, find the domain. This one is all real numbers. Both of these having square roots have to be greater than or equal to 0. So t minus 2 greater than or equal to 0, and 3 minus t greater than or equal to 0. This says t is greater than or equal to 2. Add t to both sides. 3 is greater than or equal to t, or t is less than or equal to 3. Put these together and you have bracket 2, 3 bracket. Number 2, the middle limit for the y component. We can do that by L'Hopital's rule. If you plug in 1, you get 0 over 0. So LHR, L'Hopital's rule, take the derivative of the top, -1. Take the derivative of the bottom, 2t. Now you plug in -1/2. And the others you just plug in. So 3, -1/2, cosine of 1. Number 3, x is equal to 1 over e to the t, which is 1 over y, or y equals 1 over x, which has a branch in the first and third quadrants. But in this case, you cannot have a third quadrant graph because exponentials are always positive. Okay, plug in 0, you get -1, 1. So r prime looks like that. Position vector looks like that, but the direction vector, tangent vector looks like that. Number 4, the derivative is 5, 3 cosine t, -2 sine t. Plug in pi over 3. 5 times 3 cosine of pi over 3 is radical 3 over 2. -2 sine of pi over 3 is 1/2. Think of your unit circle. Cosine is x coordinate, so looks like radical 3 over 2 comma 1/2 there. Okay, so what are we going to have? So 5, 3 radical 3 over 2, -1. And I divide that by its magnitude, which is 25, 27 over 4 plus 1. Clean that up, that comes out to be 131 over 4. Square root of 4 is 2. Apply that to the top. So 10, 3 radical 3, -2, all over square root of 131. Number 5, the z component, have to take a little time out. That was integration by parts. You might recall from Calc 2. Let u be t, dv is sine of t dt, du equals dt, and v is negative cosine t. So the integral is u times v, negative t cosine t, minus the integral of v du, negative cosine t dt. You're integrating negative, so it's just like integrating cosine, which is sine. So negative t cosine t plus sine t plus c. Okay, the other antiderivatives aren't that bad. So I is 3/2 sine of 2t, 1/2 cosine 2t, and negative t cosine t plus sine t. Okay, so plug in pi over 6, 3/2 sine of pi over 3, radical 3 over 2, minus, plug in 0, you get 0. Okay, then the middle one, y component, plug in pi over 6, you're taking the cosine of pi over 3, which is 1/2, so I have 1/2 times 1/2, minus, what do you get when you plug in 0? 1/2. And then the z component, negative pi over 6, cosine of pi over 6, radical 3 over 2, plus sine of pi over 6 is 1/2, minus, plug in 0, 0, plus 0. Okay, so this comes out to be 3 radical 3 over 4. 1/4 minus 1/2 is -1/4. And then negative pi radical 3 plus 6 all over 12. Number 6, dx dt squared plus dy dt squared plus dz dt squared comes out to be 2 plus e to 2t plus e to negative 2t. The derivatives are radical 2, e to t, and negative e to negative t. When you square them, you get this. And very conveniently, this is e to the t plus e to negative t quantity squared. So by formula, you integrate the square root of this, but the square root of this, just take off the 2. You integrate e to the t plus e to negative t, which comes out to be e to the t minus e to the negative t. Okay, so let's see. Plug in 1, you have e minus e to negative 1. Plug in 0, you get 1 minus 1, which is 0. So final answer is e minus e to the negative 1. Number 7, the derivative is t squared 2t2. Unit tangent vector, divide by its magnitude. So divide the original by t to the 4th plus 4t squared plus 4, which very conveniently is t squared plus 2 squared. So t squared plus 2. Now for the second derivative, I'm going to write this as, think of that first component, t squared over t squared plus 2. Pretend it's t squared plus 2 minus 2. That way I can write it as 1 minus 2 t squared plus 2 to negative 1. Leave the middle one alone, but the last component, the j component, or the z component, is 2 t squared plus 2 to negative 1. So these two are going to have opposite derivatives. So once I differentiate that, I got that derivative of 1 is 0. All right, so t prime, differentiate this, I get 2 t squared plus 2 to negative 2 times 2t. So automatically, the opposite of that is the derivative of the z component. So I just put a negative in front of it, negative 2 t squared plus 2 to negative 2 times 2t. Should have a bracket here. The middle component looks like I have to do the quotient rule, right? So bottom times the derivative of the top, t squared plus 2 times 2, minus the top 2t times the derivative of the bottom 2t, all over t squared plus 2 squared. Little touch up. That comes out to be, let's see, 2t squared plus 4 minus 4t squared, which I can write as 4 minus 2t squared. Okay, so I have, let's see, 4t over t squared plus 2 squared, 4 minus 2t squared over t squared plus 2 squared, and negative 4t over t squared plus 2 squared. Now, to find a unit vector, I can multiply by any scalar multiple and get an equivalent unit vector. So it's a lot easier to just get rid of all this. Just throw out all the denominators and factor out the 2. So I'm going to use 2t, 2 minus t squared, negative 2t. Okay, again, these are scalar multiples of each other. Therefore, they'll have the same unit vector. All right, so the unit normal is 2t, 2 minus t squared, negative 2t divided by the square root of this thing squared plus this thing squared plus this thing squared. This is 4t squared. This is 4t squared. This comes out to be t to the 4th minus 4t squared plus 4. And let's see, t to the 4th minus, 4t squared minus 4t squared cancels, plus 4t squared. So t to the 4th plus 4t squared plus 4, which very conveniently is t squared plus 2 squared, whose square root is just t squared plus 2. So finally, final answer is 2t, 2 minus t squared, negative 2t. Number 8, here's r. R prime is negative sine, cosine, cosine. Double prime, negative cosine, negative sine, negative sine. The magnitude of r prime is the square root of sine squared plus cosine squared, which I can write as square root of 1 plus cosine squared t. Cross product, r prime cross r double prime, ijk, negative sine t, cosine t, negative cosine t, negative sine t. So I component is that minus that, which is negative sine t, cosine t, minus a minus or plus sine t, cosine t. That's 0. Then the opposite of sine squared minus a minus cosine squared, it's going to be negative 1. And the k component is sine squared minus a minus cosine squared, so plus cosine squared. So we know that's 1, and that's negative 1. So I have 0, negative 1, 1. The magnitude of the cross product is the square root of this thing squared plus this thing squared plus this thing squared, radical 2. So kappa by formula is the magnitude of the cross product, radical 2, over this thing cubed, magnitude of r prime cubed. So I'm going to write it as 1 plus cosine squared t raised to the 3/2 power. Okay, 9, no big deal. R prime, first derivative, 1, 2t, 3t squared. Double prime, acceleration, 0, 2t, 0, 2, 6t. Now you plug in 4. So 1, 8. Let's see if I plug in 4, 3 times 16, 48. Velocity. Acceleration, 0, 2, plug in 4, 24. 0, 2, 24. The speed, by definition, is the magnitude of the velocity vector. So it's the square root of 1 squared plus 8 squared plus 48 squared, radical 2369. And finally 10, this is given r. Derivative of r sine t, cosine t 1. Second derivative is cosine t, negative sine t 0. Dot product, that times that, sine t, cosine t. That times that is minus sine t, cosine t. They're going to cancel out. Plus 1 times 0, which is 0. So the answer is 0. Okay, and then the cross product, r prime cross r double prime, I, j, k, and the components of what? R prime sine cosine 1 and r double prime cosine negative sine 0. And looks like I botched this up a little bit. But the I component is nothing minus a minus sine t, so sine t. Then the j component is the opposite of nothing minus cosine squared t. And the k component is negative sine squared minus cosine squared, which we know to be negative 1. So I have sine t, negative cosine t, negative 1. Okay, so what's the magnitude of the cross product? Magnitude of r prime cross r double prime, sine squared plus cosine squared plus 1. That's 1 plus 1, so square root of 2. And the magnitude of r prime is the square root of sine squared plus cosine squared plus 1 squared. That's 1. There's another one, so radical 2. So by formula, a sub t is dot product over radical 2. Magnitude of the cross product, it comes out to be 0. A sub n is radical 2 divided by radical 2, which comes out to be 1. Okay. All right, so these solutions to Milham's Calc 3 Exam 2, the 5 p.m. section.